Okay, guys, so we're going to be graphing standard form quadratic functions. Bless you. Graphing. Now, back in the past, we would graph lines, right? So if I had y equals 2x plus 1, there was a certain way of graphing that equation, y equals 2x plus 1. The shortcut was to understand the form that it's in, and it was y equals mx plus b. And the b value tells you where it crosses your y-axis, which would be at the value of 1. So you'd put a dot right there. By the way, you don't have to copy this down, just watch and understand here. And then from that point, you rise and run according to your m value, which is 2. So as a fraction, the m value would be 2 over 1. So you would go up 1, 2, bless you again, and over 1, and you would get to that point right there, and that would be the line that you graph, going right through those 2 points. So that was a shortcut to graphing a line. The original method we learned on how to graph lines was to use an input-output table, which is an XY table, right? And the input-output table works for any type of function. It doesn't have to be a line. You could use it on parabolas or any type of graph. And what you do is simply plug in some easy numbers, like you could plug in a 0. And if you do plug in a 0 into the x right here, 2 times 0 is 0, and 0 plus 1 is 1. That's a coordinate, 0, 1. And if you think about 0, 1, that's that red dot right there. Then you could plug in another number like 1. And if you do plug in a 1 right there, 2 times 1 is 2, plus 1 is 3. So you get out a 3. And that's a coordinate 1, 3. 1 on the x, 3 on the y. There it is, that blue dot. And you could continue plugging in any numbers you want. Like if you plugged in a 5, 2 times 5 is 10, 10 plus 1 is 11. That means that if you went out to 5 on the x, you'd have to go all the way up to 11 on the y, and it would be perfectly on that line. So we remember that, yeah? Fantastic. Now we get to move on to graphing parabolas. So if we take a look at these notes that we just handed out, it says that this is a standard form quadratic trinomial function. Now we should already know what a standard form is: the highest exponent down to the smallest, down to the constant at the very end. We should all already know that the a value, b value, and c value are just numbers. So what I mean by numbers, like, as a matter of fact, if you want, you could put like a little number symbol on top of the a, on top of the b, on top of the c. So an example of a quadratic trinomial would be like 5x squared plus 3x plus 2, right? Or maybe just a regular x squared. Maybe you don't have a number here. Maybe the a value is 1, right? But you're going to have numbers in a, b, and c. And you might not even have a b value. You might not have a c value. But this is a standard form quadratic trinomial. A, b, and c are just numbers, okay? So like I mentioned at the beginning of the video, up until this point, we've only graphed lines, y equals mx plus b. Today, we're going to begin to graph parabolas. And parabolas are U-shaped curves that either open up or down. So the most simple parabola would be the function y equals x squared. And y equals x squared is what we call the parent graph. All parabolas are going to kind of look like this parent graph, y equals x squared. And we're going to start graphing this the way we would graph any function with the input-output table. So everybody go ahead and write down a xy table right here. And let's plug in consecutive integer inputs. That means numbers that are in order. And I'm going to go with like -3, -2, -1, 0, 1, 2, 3. Okay? So when I plug in, let's go with 0. 0 is the easiest. What's 0 squared?
0.
0, that's right. So when I plug in a 0, I get out a 0, right? When I plug in a 1, what's 1 squared?
It's a 1.
It's a 1. When I plug in a 2, what's 2 squared?
4.
It's 4, that's right. When I plug in a 3, 9. 3 times 3 is 9. Okay, great. What if I plugged in a -1? Now remember, when you plug in a negative, or when you plug in any number, you're technically supposed to plug it in, bless you, with parentheses, right? So it should look like this. Y equals, plug in the -1 right in there, and then it's squared. So what is -1 squared? 1. So we get 1. How about -2 when I plug it in -2 squared? 4. And 9 also, okay? So these are all coordinates. Let's start with the most important coordinate right here, the one in the middle, 0, 0. Let's put a dot right there. And then let's go to the coordinate 1, 1. And let's put a dot right there. That means one on the x, one on the y, right? One to the right, one up. And then do 2, 4. So 2 on the x, 2 to the right, 1, 2 from the origin. And then up 4, 1, 2, 3, 4. Put a dot right there. And then go back to the origin, 0, 0, and then go 3, 9, right? The coordinate 3, 9 from the origin. 1, 2, 3 on the x, all the way to 9. I know this is a 10 by 10 graph, so it's 1 unit off of the edge. So it's right here. 3 on the x, 9 on the y. Let's put that dot right there. And then if we started graphing these other coordinates, the negative 1, 1, that's negative 1 on the x, positive 1 on the y, we end up with a dot right there. And then if we go to negative 2 on the x, 4 on the y, it's right there. Negative 3 on the x, 9 on the y, it is right there. Okay. Now you might be thinking, why did I put these dots in blue? I'll explain that in a little while. But right now, let's connect our dots, and we have our parabola. The very first parabola that we graph is the parent graph, y equals x squared. Well, we're going to be able to also be able to see how if you throw something up in the air, it's really a parabola that's opening down. Actually, yeah, anything that goes up must come down, and it travels in the form of a parabola, even missiles, right? Anyway, this is a parabola. We call this the parent graph of all parabolas because all other parabolas are going to look like this one, but they might be wider, or they might be narrower, right? Or they might be down here, like with the vertex down here. By the way, I said the word vertex. Let's start with that. The vertex is the most important point. So I'm going to put this dot right here. I'm going to make it black. And I'm going to write the word vertex right there. Vertex. That black dot right there is the vertex. Go ahead and label it. I know you might not have different colors.
Also the middle part?
Yeah, that dot right there, the middle part is the coordinate 0, 0, and that's what we call the vertex. This coordinate right here, 0, 0, is the vertex. Now, the vertex obviously is not always going to be at 0, 0. It might be down here and opening up, or it might be down here opening down. The vertex is hands down the most important point of any parabola because it tells you where it's located. It's either the highest point or the lowest point of a parabola, okay? So that's what a vertex is. So if you were to throw something up in the air, like, okay, so imagine this dot. If I threw this up in the air, it would go higher and higher and higher and then eventually reach a max point and then come back down, all right? That's the vertex. The highest point is the vertex, or the lowest point is a vertex. Actually, let me demonstrate that. Okay, so if I throw this up in the air, that traveled in the path of a parabola. So, watch this. Uh-huh. So something like that, right?
And you got it.
I think it's a little higher up. Anyways, the idea is that it does travel in the path of a parabola, but this parabola is opening down instead of up. So it does travel in the path of a parabola, but opening down instead of up. Okay, so back to the parent graph. There's a couple other things I want to mention. Through any vertex, yeah, the vertex is the most important point because it's the middle, and through that middle point, it's either the highest point or the lowest point, depending on if the parabola opens up or down. But through that vertex, there exists a vertical line. I always use a green dotted line, and that green dotted line is called the axis of symmetry. Axis of symmetry. Go ahead and jot that down in your page of notes right there. Now, the axis of symmetry, what does the word symmetry actually mean? Same thing on both sides, exactly. So when you draw this vertical line right through that vertex, it produces a reflection on both sides. If I were to, if I were to get this paper and fold it right on that axis of symmetry, this blue dot would land perfectly on top of the red dot. The red dot would land perfectly on top of the blue dot. There's symmetry on both sides. This red dot's 2 units away, this blue dot's 2 units away. So the axis of symmetry is always going to be, because it's a vertical line, it's always going to be x equals a certain number. And that number will be the x value of your vertex. Okay, in this case, x equals 0 would produce this vertical line right here. Okay, so the axis symmetry is going to be x equals the x value of your vertex. Anyway, it's a lot of stuff. As you can see, the definition for vertex is already written right here. The vertex is a coordinate. It's either the highest point or the lowest point of your parabola, depending on whether it opens up or down. We already talked about that. Now, this is super, super important right here. Highlight it, circle it, underline it, whatever. Has 3 stars. If the A value is positive, it opens up. If the A value is negative, it opens down. Very important stuff. Now, what is the A value? The A value is the number that's out in the front, right? This is your A value right here. So if it's a positive number, the parabola will be opening up. If it's a negative number, the parabola will be opening down. Okay. Actually, what I would like you to do right now is open up your Chromebooks. I know it's kind of offbeat here. Open up your Chromebooks and go to desmos.com. Just want you to check out a couple of things. I want to graph this exact parabola that we already graphed by hand, y equals x squared. Let's go to Desmos and actually graph that. So I just graphed this on Desmos, but I need you guys to do that. So if you got this, well, first of all, I want you to notice that on the original screen, you're not going to have it in single digits, like as in right here it goes 2, 4, 6. I would like it to be 1, 2, 3, 4. So please zoom in a little more till you could actually see 1, 2, 3, 4, okay? And of course, you could move your screen around to get a better angle. So I zoomed in so you could actually see the units 1, 2, 3, 1, 2, 3. So I zoomed in enough so I could see the single units on the XY plane. And this is the parent graph, right? Yeah. Now, what if I actually changed that A value, the number that's out here in the front, the A value is 1 right there. There's a 1 right there. What if I change that to a negative? Put a negative sign right in front of it. It's going to open down instead of up, all right? So go ahead and do that real quick. So hopefully you guys typed in that negative sign in front and you saw that instead of opening up, it opens down. Yeah? Okay, let's go back to the original parent graph and make it just a y equals x squared again. And then from there, what I would like you to do is to change your A value. Right now it's a 1, right? What if you made it a 2? Go ahead and change it to a 2. What's going to happen? So I hope you guys noticed that when I changed it to a 2, it got narrower. Okay, and that's technically called a vertical stretch. Okay, it gets narrower when it gets vertically stretched. So for example, actually let me type this up and then show it. Hold on a second. Okay, here we go. So I put 3 graphs on Desmos at the same time. You should be able to see that the first one in red is the parent graph y equals x squared, which has an A value of 1. If I make that A value 2, it becomes the green graph. That's called a vertical stretch. So it gets narrower because it got vertically stretched. Does that make sense? It's kind of like, so if you have an A value of 1, it's a regular parabola that opens up. If you have the A value of -1, like y equals negative x squared, then that would open down instead of up, right? But if you have the A value of 2, then what happens is it gets vertically stretched. So it's like if somebody were pulling my hands up, then the parabola gets narrower, right? So A value of 1, y equals x squared. A value of 2, y equals 2x squared. A value of 7, y equals 7x squared, right? So it gets more narrower, right? So that's what you call a vertical stretch. And the other one, when it gets wider, that's what we call a vertical compression. So those are vocab words that you're going to be using the rest of this school year and also in Algebra 2. So, okay. So, y equals x squared, y equals 2x squared, y equals 7x squared, right? Back to y equals x squared, A value is 1. What if I want y equals 1/2 x squared? That'll make it wider. Y equals 1/10 x squared, make it wider, right? The closer you get to 0, the wider it gets. If you actually got to 0 and it was y equals 0x squared, it would get so wide that, bam, it's flat. Y equals 0x squared is just y equals 0, which is a flat line. Does that make sense? Okay, so the A value tells you so much about a parabola. If the A value is positive, it opens up. If the A value is negative, it opens down. If the A value it becomes 2, it gets narrower. 3, narrower. 4, narrower, right? Or if it gets closer to 0, from A value of being 1 to 1/2, like instead of y equals x squared, it's y equals 1/2 x squared, it gets wider. 1/10 x squared, wider. 1/100th x squared, really wide, almost a flat line. Make sense? Okay, cool. So I hope that made sense, and that's why as the A value increased, this thing got vertically stretched, it got narrower and narrower. If I were to type in something like y equals 1/10 x squared, then that would be a really, really wide parabola, right? The closer that your A value gets to 0, the closer it gets to a totally flat line. I apologize. We're covering so much right now. And like I said, we're not going to learn anything more throughout this week. We're going to stay with this. We're going to get comfortable with all the vocab. So right now we should know what a vertex is. It's the most important point. It opens up or down. We should also know that the A value is super important because it tells you if it's opening up or down. It tells you if it's wide or narrow. The closer you are to 0, the wider it gets. We also know what the axis of symmetry is. It's that line that'll chop it perfectly in half right through the vertex. And we should know it's the equation x equals the x value of your vertex. Okay. And down here, I explain all that. And here's the first formula that I'm going to ask you to memorize in this chapter. The formula is the vertex formula. So what is the vertex? It's the most important point. It is a coordinate. So we all should know that a vertex is a coordinate. It's an x value and a y value. So you need a number here and a number there for the vertex. Now, this formula that I'm asking you to memorize gives you the x value. It says x equals negative b over 2 times a. So where are we going to get these b and a values from? You're going to get them from your standard form quadratic trinomial equation. So the formula says negative b over 2 times a. So whatever number is here, you're going to put a negative in front of it. So yeah, it doesn't, even if b is negative, you would plug it in negative b, so that'd be a negative negative, whatever number this is, divided by 2 times a, and that'll give you a fraction. That'll give you your x value. And anytime you have your x value, that'll give you this number. And anytime you have this number and you want the y value, all you got to do is plug it in to find out, right? Like on any equation, look, watch, forget about parabolas for a second. Even if I said x plus y equals 5, and I told you, hey, x equals 2, what's y? 3. How do you know that? Well, you actually, in your mind, you plugged it in, 2 right there. 2 plus what is 5? 3. So that's how you figured it out. So when you have an answer and you need the other, just plug it in and find the other answer. Anyway, let's go back to the notes right here. So remember, the vertex is actually a coordinate. This formula will only give you the x value. You still need to plug it in to find the y value. And we already said the axis of symmetry is that vertical line that passes through the vertex, and it will always be x equals the x value of your vertex. So if the formula I just gave you gives you the x value of your vertex, then technically the axis of symmetry formula will be that exact formula, x equals negative b over 2a. Anyway, let's look at the steps here to graphing a quadratic and apply them. Step 1 is to find the vertex, okay? So let's do that. Let's all go to this one right here, and let's plug in our vertex, or let's find out our vertex. So everybody put step 1, vertex, put a coordinate, and we're going to find this coordinate by using the formula x equals negative b over 2 times a. Now, when I use the formula, I recommend using parentheses and then filling in those values according to your b and your a. In this case, explain that. Sorry about that. So here we go. When I plug in the b value of 6 in here and the a value of negative 3 down there, and we do the math like you guys just said, it's negative 6 over negative 6, which is really just 1. So with the formula, I found out that my x value is 1, and the x value is 1 in the vertex. Remember, a coordinate is really an x and a y. You just found that x equals 1. Put a 1 right there. How do you find the y if you already know x? Plug it in. So if you're writing down notes, you would say like plug it in to find y. Okay? So plug it into what? Into the original. So I'm going to write it out. Y equals negative 3x squared, but instead of x I put parentheses, plus 6x, instead of x I put parentheses, plus 5. And inside those parentheses I put the 1 that I'm substituting in for x, because I know that x equals 1, because I use the vertex formula to find out x. Now let's do the math. And of course, when you have multiplication, exponents, addition, multiplication, and addition, you start with exponents. 1 squared is 1. So I would start with 1 squared. That's just a regular 1, but you still need to multiply it by that -3 in the front. So -3 times 1 is -3. And then 6 times 1, that is 6. And the plus 5, you could just bring it down. So what we really have here is y equals -3 plus 6 plus 5. Y equals 8. Okay, so we just found our y value of 8 of the vertex. So we said before that the vertex is the most important point. It's the coordinate 1, 8. So let's go to that coordinate. 1 on the x, 8 on the y. So 1 on the x, 8 on the y. That would be right here, close to the top. So instead of the vertex being at 0, 0, this vertex is at 1, 8.
Then you go to your XY table, right?
Yeah, then you go to your XY table, but I already know something about this parabola. What do I know about it? It's going to open down, and it's 3, which means it's going to be narrower than usual, right? It's going to be vertically stretched. It's going to be narrower than usual. And we'll see that right now as we go through the motions with the XY table. So everybody right here on this side, go ahead and put an input-output table. And let's plug in some easy numbers. What would be the easiest number to plug in? Oh, you know what? Even before finding more coordinates, through the vertex exists that vertical line that we call the axis of symmetry. So we might as well do that right now. So here is my axis of symmetry. Everybody go ahead and draw a vertical line. I always use green. It's a green dotted line. That's my axis of symmetry. Not only that, if I wanted the equation of this axis of symmetry, it would be x equals the x value of our vertex. And what's the x value of our vertex? 1. So that would simply be the equation x equals 1. So there will be questions on the quiz where I just give you a quadratic trinomial function and I tell you what's the axis of symmetry. You got to type in x equals 1. And how do you know that? Because it's the x value of your vertex. And like I said, we're going to be working on this all week. So if you're not, don't expect to memorize everything this hour, but you will by the end of the week. Anyway, now when I find another point, I'll be able to reflect it over this axis of symmetry, which will actually give us 2 coordinates instead of 1. So you guys mentioned an easy number to plug in. What would it be? 0 is the easiest one to plug in. So if we do plug in 0, imagine that. 0 right here where x is at, 0 squared is 0. -3 times 0 is 0. And 6 times 0 is 0. And 0 plus 0 is 0. But 0 plus 5 is what? 5. So we end up with the coordinate 0, 5. Let's all go to 0 on the x, 5 on the y, 1, 2, 3, 4, 5, and put a dot right there. I'm going to put a blue dot right there. And not only that, we could reflect it over to the other side of this axis of symmetry 1 unit away, and it'll be right there. And technically, we already have a pretty good idea of how this narrow parabola is going to look like so. Now, of course, if you want more points, you got to plug in more x values to get more y values, right? Get more coordinates. So would it be smart to plug in a 1? The answer is no. And I'll tell you why. Because you already plugged in a 1. Didn't we plug in a 1 for the vertex? And we got out an 8. So if you did plug in a 1, you're just going to find that 8 again, and that'll be the coordinate 1, 8. So would it be a good idea to plug in 2? No. You know why? Because we already know with the reflection that at the x value of 2, your y value is going to be 5. So 3 would be a good one, or maybe -1 would be a good one, right? Let's go with 3. So if I plugged in 3, what will I get? Well, 3 squared is 9. 9 times, maybe I should show my work. So I just rewrote 3x squared plus 6x plus 5 up here, but instead of x's, I put parentheses and I'm going to plug in that input of 3. So when I do this, 3 squared, that's 9. So I have a 9 times -3. 9 times -3 is -27. And then 6 times 3 is 18. And then plus 5, that's what I need to figure out. What's -27 plus 18 plus 5? I think that'll be a -4. So when I plug in a positive 3, I get out a negative 4, and that's actually a coordinate. Let's go to 3 on the x, 1, 2, 3. Negative 4 on the y, 1, 2, 3, 4. Put a dot right there. And of course, you could map that over to the other side. How do I do that? It's 2 units away from that green dotted line, so go 2 units this way and put a dot right there. And that way you could extend this parabola all the way through those points. Is there an easier way? Yes, thank God. And we're about to discuss that right now. But we will, I guess, go over that tomorrow. Okay. But, let me just give you a little taste. Just a little taste. Okay? If you know that the a value of 1 is a parabola that opens up, when you know your a value is 1, you know that you end up with this parabola. And if you know that the a value affects how wide or how narrow it is, then any parabola with the a value of 1 is going to be exactly as wide as this one. It's a perfect U-shaped curve. It's not going to be wider, it's not going to be narrower. So any equation that has an a value of 1 will be exactly this width, and we'll pick that up tomorrow.